Okay, we've talked a little bit about radicals before, okay, just kind of simplifying them and what does it mean when we see this symbol. Now we're going to talk about multiplying, dividing, and simplifying them when they're not perfect squares. Before, the ones we talked about simplifying, we had things like square root of 25, which we said was 5. But what if it's square root of 24? And there's not one particular number that you can multiply by itself and get 24. Okay, we have a product rule and a quotient rule. Now, really, we've already used this quotient rule in simplifying. Recall we said if we have something like square root of 49 over 36, I know that all I have to do is think of the square root of 49 and the square root of 36 individually. Okay, so the same thing happens if you're multiplying. And there's an equal sign, so this works both ways. So in other words, as long as the only operations are multiply or divide, right, we can do the root first and then do the operation, or we can do the operation first and then do the root. Just be careful. It doesn't work with adding or subtracting. Just like everything else, we got to look out for those plus or minus signs. So we're going to use these rules to help us simplify radicals. And just like with fractions, it goes without saying that it's always got to be simplified, right? If we have trouble finding the factors we need, do the prime factorization. Okay, so what we are looking for is I'm just asking myself, well, are there any, I know square root of 24, I know 24 isn't a perfect square, but are there any factors of 24 that is a perfect square so that I can do the square root of at least part of the factors? Okay, so let's do our factorization. And really, this time now, I would really, if I was just doing the prime factorization, I'd write that as 2 cubed times 3, right? That's the prime factorization for 24. But what I want to do, if I'm using my prime factorization to help me simplify a radical, I want to write it all in groups of 2. So I'm going to write 2 squared times 2 times 3, groups of 2. And then I'm going to use this property up here that says, hey, I can separate every one of those factors into its own radical. Okay, so that means this one right here, because this is a square root and this is a square. Think about that. What's the square root of 4? Oh, it's 2. That's going to cancel itself out. And what I'm going to have left is just that 2 without the radical sign, because really it was square root of 4, right? Now these 2 that's left, they don't have exponents on them, so I can't reduce that any farther. So then I'm going to use this rule here in reverse that says, hey, I can put them back under the same radical. So the radical is going to stay on these, and it's going to be 2 times 3, which is 6. So this is 2 square roots of 6 is the simplified form of square root of 24. Okay, let's do it for the next one now. All right, remember, a negative outside just means your number is going to be negative. So I'm going to do my factorization. This is 6 times 100, or whatever you see, 60 times 10. However you want to start is fine. We'll all get to the same place in the end. Okay. So instead of writing this as 2 cubed times 3 times 5 squared, I'm just going to do them in pairs. So I've got 2 squared times 2. Maybe you want to keep up with what you've already used. And then there is a 5 squared. There's 2 5s. And then there's just 1 3. Okay? So I can separate these under their own radical sign. That's my product rule, as long as I'm only multiplying. And now I see that any of them that have an exponent of 2, that'll get rid of the radical sign. Any of them that have an exponent of 2 will get rid of the radical sign. So if I were to write this out now, I'd have just the 2, and then that one has to stay under, so I've got a square root of 2. Then just the 5, and then the 3 has to stay under. Okay? Multiplication's commutative, meaning I can change the order. So I'm going to put these 2 together because they're the same kind of number, and these 2 together because they're the same kind of number. Right? So 2 times 5 is 10, and the ones under the radical is 2 times 3. Now, don't forget it had this negative, so really, my answer is negative 10 square roots of 6. Okay, I'm going to erase all this because I don't have room. So if you need to see that up there a minute, you might want to pause the video. All right. So 6 times 5, 2 times 3. Now look at this when I do this prime factorization. I don't have any of them that I can write with an exponent of 2. So that means that won't simplify. It's already, well, it's simplified as far as it'll go. It won't simplify any further. All right, let's do this one. Okay, so I can change this. Now don't forget we've got the 5 out front, so it just stays there. But then I can change it times square root of 2 squared, right? And a square root of 7. Now this will cancel that radical sign. So really this is 5 times 2. And then the square root of 7 stays. Okay, let's do just a couple more examples. Okay, so this one, I can just do my prime factorizations on all of them as long as it's only multiply or divide, right? I can do them all together. And notice, oh, then I get a 2 squared times 3. 2 squared and a 3. Make sure you've used all your factors. Well, this can go under here, which means it gets to undo itself and just leave a plain 2. But because there's only 1 3, it has to stay under that radical. Okay, this one, my fraction won't reduce. So I'm going to think of it as 2 separate problems. And the square root of 13, 13 is its own prime factorization, right? It doesn't have any other factors. So that means, okay, well then it won't go any further. I can't write any factors with the square, but oh, square root of 25, that's 5. Because It's this, right? So it's just 5. Okay, let's look at this one. I'm going to think of this and this fraction separately. 50 divided by 2 is 25. And then, because of my quotient rule, as long as they're both under a radical, then I can put them under one radical if I want, so I can simplify it just like I did these. Right? So 20 divided by 10 is 2. And the 2 doesn't simplify any further. So we use these rules whichever way helps us. Either by separating them so I can do a part, or if I put them together under one so I can simplify. Right? It goes both directions. I can separate them or I can put them together. As long as it's only multiply and divide. No adding and subtracting. No adding and subtracting. We'll talk about that momentarily. All right, let me know if you need anything.